The relationship between physics and economics may have started with Adam Smith using Newton's equations, but today we will limit the relationship between these two disciplines to stock markets and quantum physics. It seems that the similarities between the behavior patterns of quantum physics and financial markets have caught the attention of physicists, as we see that many predictive models on this subject began in the 1990s. This evolving discipline has been named quantum finance and has started to be used in many financial areas, including stock price predictions. Quantum mechanics is the theory that describes the subatomic microworld. We can very simply define this theory with the uncertainty principle, wave-particle duality, superposition, and the incredible state of entanglement. Let's also state that the elements of the subatomic microworld constitute the macro world. When we look at spot or derivative stock markets from a very simplified perspective, we see that stock prices, under the shadow of the uncertainty principle, can fluctuate to any level at any moment, but the transaction is always executed at a single price. At the end of the day, the stock prices, which we can call microparticles, define the index, which we can call the macro structure. If the initial similarities between these two different worlds we just mentioned have excited you, we have included the addresses of a few models made on this subject in the description section. When we look at the common features of quantum physics-based models developed for stock price predictions, we see that while there are many reasons to be convinced that stock markets operate under quantum rules, there are also many reasons not to believe this argument. It is useful to say that the models made for derivative products are more realistic. When we look at the main feature of the models developed for stock price predictions, we first see that it is assumed that stocks behave like subatomic particles, that these financial particles define the index, and that the indices behave like macro assets. Whether you find this approach convincing or not is entirely up to your evaluation. However, it is possible to find thousands of examples where the behavior patterns of a stock price are not related to the index it is included in. For example, news of war can cause stock market indices to plummet while the prices of defense industry stocks soar. While this approach may be acceptable in terms of illustrating that the subatomic world and the macro world do not behave separately, it does not seem very convincing in terms of proving that financial examples have quantum properties. Another analogy is the volatility of stock prices, or the fluctuation of prices over time, being considered as the wave property of financial particles. These models also consider any transaction being executed at a single price at a single moment as the particle property of the financial particle. This approach is advanced by suggesting that stock prices behave like both waves and particles, thus having wave-particle duality, and therefore can be explained by quantum mechanics. From this perspective, it may be possible to say that the entire world of commerce has quantum properties, but it seems to overlook the fact that the quantum world exhibits particle properties in the presence of an observer. Clearly, this analogy, which involves a very formalistic and simplistic approach, is highly debatable, and I leave the discussion to your comments. Another analogy is related to the principle of superposition. Assuming that there are no daily price limits in the stock markets, the fact that a stock's price can take any value until a transaction is executed is associated with the superposition state of subatomic particles. The superposition state implies that the energy or position of a subatomic particle can be described as a sea of possibilities, and that a quantum system can exist in a combination of multiple states simultaneously. When a measurement is made on this system, the superposition state collapses into a specific state according to the result of the measurement. When you buy a stock at a selected price, you are collapsing the superposition state, that is, making the measurement. Now let's get to the golden question. Is it possible to make money from the stock markets using quantum modeling? If you are well versed in quantum physics and mathematics, and have a high level of knowledge in the fundamentals of economics and financial modeling, who knows, maybe you can create your own models. While we recommend consulting an expert before making any investment decisions, we would like to remind you that free cheese is only found in a mousetrap. If you would like more content on quantum finance, which we have covered at a very basic level, please mention it in the comments. See you in the next video.